All right, so what we're going to do today is going to be relatively quick. It's going to be taking a look at one of the things we ended with on last Wednesday. Again, everything that we're talking about is just an extension to move into next year. It's not required, but I do want to give you those options as they are. So last week, what we looked at was our unit circle. As we finished the section, we talked about radians, arc length. We moved into how to change things from degree to radians and back from radians to degrees, depending upon what unit of measurement we were looking for. We then talked about the common radian measures that went with our common degrees. And I brought up a little bit of what would happen with the unit circle. And you can kind of see that when we talk about the unit circle, we're talking about one unit of measurement for the radius. And we talked on Wednesday, as the radius moves, it starts to make these different right triangles in each of the quadrants. So one of the things that we talked about in geometry last year were our special right triangles that can help us figure out exact values of where this number is. So what we're going to do is we're going to look at real quick, even though I kind of told you take a look at it, see what you can come up with. We're going to look at how to find the measures in the first quadrant, and then what's going to be your job, if you so choose, is to find the measures of each of the coordinates, I should say, from the other quadrants. So then we did finish up with arc length using our different formula with radians and kind of how our circumference formula came about. And we finished up with, I gave you the PDF yesterday if you were interested and had put some thought into it. I kind of held off a little bit so that now you're looking at what each of these are. So with that being said, one of the things that we have to remember is it is called a unit circle, which means one unit of measurement. So right now, if we're at 0 degrees or 360 degrees or 0 radians or 2 pi radians, what I want to make sure we are aware of is that we are out here at 1, 0, meaning our x coordinate is 1, our y coordinate is 0. As we take this radius and shift it all the way around, we're now straight up and down here. Our x coordinate is 0, but our y coordinate is 1. We're back here on our x-axis. So our x-coordinate is -1, y-coordinate is 0. And then down here, remember, our x-coordinate is 0, but our y-coordinate is -1. So at least those four should be fairly self-explanatory, and they can remind you that our radius in each situation is 1. So now the issue is, how do we figure out what each of these coordinates are, depending upon what each of these measures are? So the first thing that we're going to do is we're going to look at this first coordinate right here. And right now we know that if we were on our protractor, we've opened up our angle to 30 degrees. So if our arc is 30 degrees, our central angle has to be the same. Again, that's something that we bring back from geometry. The central angle is equal to the arc it contains. So we're going to set that aside, and we're going to take a look at this 30. It doesn't look like a 30-degree angle. That's going to bother me. So I'm going to flip it over. And what happens is, as we have our semicircle, or at least this quarter circle that we're looking at, we again said that it reached out to 30 degrees, which means our central angle is also 30 degrees. When we drop the vertical, this is our ordered pair that we want to take a look at. We want to know what that x coordinate is. Well, what we've also done is we've created a 30, 60, 90 situation. And what we're supposed to remember from honors geometry, from geometry, is that the minute this happens, we have a formula that actually exists around our triangle. Opposite the 30, adjacent to the 30, and then we have our hypotenuse. So we've been dealing with sine, cosine, and tangent. The issue is with sine, cosine, and tangent, you don't get exact value answers. You get rounded answers. So what we're looking for is our special right triangle formulas. Opposite the 30 is 1 of something. Opposite the 60 is something radical 3. And opposite the 90 is 2 of something. Well, when we look at this, we know that this was our radius. So we have to remember that's our radius. And it's a unit circle, so our radius is 1. So going back to kind of how I did things in geometry, once we know what the formula is and we know that we have a value on that side, we set them equal to each other. So 2a equals 1, which means, or I should say, notice how I switched my variables. I'm so used to using a's in geometry, I forgot. Let's make that an x. So 2x equals 1, which means x is 1/2. So this side is 1/2. And this length is 1/2 times radical 3. And if we write that the way it's supposed to, it's radical 3 over 2. So if the length is radical 3 over 2, that means this x coordinate is radical 3 over 2. The vertical, how high did we go? That means our y coordinate is 1/2. So here was our horizontal distance. Here was our vertical distance. So our ordered pair right here, what we're looking for is going to be radical 3 over 2 and 1/2. So right here, radical 3 over 2 and 1/2. So now what we're looking at is how would we approach our 45-degree angle. So again, if we're going to look to drop that vertical to figure out where does it intersect our x-axis, drop our vertical, where does it intersect our x-axis to know what the x-coordinate is. Again, the vertical distance would tell us where our y-coordinate is. So we're going to have to set this up with a 45, 45, 90 right triangle. Let's get a better view. So now, and because again, where our arc would rotate, we know that the central angle is equal to the arc it contains. If this was in our first quadrant of our unit circle, we would drop our vertical. So remember, this is our x-axis. So right here, we now want to write our formula around our 45, 45, 90 right triangle. So opposite the 45 is x, x, and x radical 2. Well, remember, this is still our radius. So the hypotenuse is always our radius, which means this guy is still 1. So like we did in geometry, you're going to take this side, set it equal to each other, x radical 2 equals 1. And when we divide, we end up with 1 over radical 2, which we know as a final exact value answer. We can't leave the radical in the denominator. When we rationalize, don't forget that that does mean multiply by a radical that makes it a perfect square, which in this case is by radical 2 itself. And we end up with radical 2 over radical 4, which does simplify into x is radical 2 over 2. And most of you remember that the shortcut is drag the radical to the top, write just the number on the bottom, and then simplify from there. So that means that this distance out to this point is radical 2 over 2. So that means this x coordinate is radical 2 over 2. This distance up is also radical 2 over 2, which means the y coordinate is also radical 2 over 2. So when we come back to our unit circle, our x coordinate went out to radical 2 over 2, and our y coordinate went up to radical 2 over 2. All right. Now, the only other thing, which is actually going to be the same as what we already did, is our 60-degree angle. So again, we have our x-axis. We're going to draw our 60-degree angle. We can't forget that this is our radius again, so that's a value of 1. The 60 is going to be equal to the arc it contains, so we went 60 degrees this way. And now we're going to drop our vertical again. And here's our 30-degree angle up there. And if I label this, opposite the 30 is x, opposite the 60 is x radical 3, and opposite the 90 is 2x. So we actually already know that x is going to be 1/2. We've already done that up here because that's not going to change. So we know that x is 1/2, and we know that this is going to turn into radical 3 over 2. So it just flip-flops. The difference is when we do mark our coordinate, we have to make sure that our x coordinate is now the 1/2 and our y coordinate is now the radical 3 over 2. I am going to stop there because all the way around now this unit circle are the same central angles. So for instance, when we move in this direction, we still have that 60-degree angle that we're working with. We still have our 45 and we still have our 30, even though these measures do say 120, 135, 150, 180, and much bigger at the bottom. They're still only from here 60 degrees. So you still have that 60-degree triangle here, the 45-degree triangle here, and the 30-degree triangle here if you just work with the quadrant. The other thing you have to remember is your positives and your negatives. What's positive in your coordinates and what's negative in your coordinates. Remember, your x coordinates have to be negative, your y coordinates have to be positive. And down here, what's positive and what's negative is anything. Same thing over here. So make sure that your ordered pairs match the quadrants that they're in. So just a little bit of a review on the special right triangles from last year. See if you can fill in the unit circle. I will post the work that we did with the unit circle and with it all filled in. But again, that's just to make sure that you kind of know where those values are coming from, because eventually all of these values, this 1/2 and this radical 3/2, will come into play again, as well as the radical 2/2 and so on. So that's all I have for today. Keep working on your past materials. I will keep working on getting the grades in, and we will meet back on Wednesday if I have any questions.